Hello guys, welcome to Mathematics and 5. Today we are talking about logarithmic differentiation. So this is part of question 2 of your final examination, logarithmic differentiation. So in this chapter we will be mainly uh, dealing with natural log, which is your ln. So most of you call it in, it's not in, it's natural log, so it's ln. It's ln. Okay, so before we have to discuss the basic natural log operations, because you will be meeting some of them when you do when you write or like practice on your own or in class. Okay, first one is ln of e. Ln of e is 1. Keep that in mind. Number 2 is ln x exponent a. Remember when we were dealing with normal logs, we said if you have exponent, that exponent can come before your log. So natural log and log, they have the same operation exactly. So if I have ln x exponent a, that a will come before, so it will be a ln x. So if I have a ln of a product, you know, that means you can divide your ln into a sum. So it will be, if I have ln a multiplied by b, it will be ln a plus ln b. But if it's a quotient, ln a over b, then it will be ln a minus ln b. Okay, so I want to quickly introduce how this logarithmic differentiation works. So this is what you are going to do, steps to follow. This is steps to follow to do your log differentiation. Number 1, apply your natural log both sides. Next step, differentiate respect to x, which means dx. Then after differentiate, solve for dy dx, or make it subject of the formula. Then at the end, substitute y. Okay, I'll make a very quick easy example here on the side. I don't need too much space. So if I apply all my steps, let's say I have y, it's e exponent x. I want to differentiate this using logarithmic. So step 1, I'll apply logarithmic both sides. So instead of doing that second step, every time you can just skip from here, go straight here, because we know that exponent will come before your ln. So every time if I apply, I don't have to write these 2 steps. I can just write x ln e, right? And what do we know? We know x ln e is equals to 1. We know this is 1. Then now the next step, now I have ln y equals to x. The next step is to what? Differentiate. If I differentiate ln y, I'm getting 1 over y. Because I differentiated y, I put dy dx. This side, if I differentiate x, I get 1. So do you see? Then now I must solve for dy dx, which is step number 3. Dy dx will be equals to y, because I have to multiply both sides by y. Then the last step, substitute that y. Remember y from the beginning, it's ex. So your dy dx equals to ex. But obviously when you write, it will be more complicated. Yeah, it won't be that easy. I just wanted to show you the operation in step-by-step form. So yeah, let's quickly do some examples and see if we can get it. Okay, That's question 2. Okay, let me see what I have here. Okay, let me do this. Okay, let's say we have that question and they say determine dy dx using logarithmic. So the question that will specify every time it's a separate question, because you have your questions are divided in question 2. There's normal differentiation where they don't tell you which methods to use. Then there's a question where they say with the aid of logarithmic differentiation. Then this last question which they say implicit differentiation. So this one they will specify logarithmic. So first step is to apply your ln. Remember I said that second step of writing ln e exponent, that we can just put sign before your ln, because we know sign will come to the bottom, and we know ln e is 1. So I have ln y equals to sin x. Then if I get here, now I'm ready to differentiate. Now differentiate your ln y is 1 over y dy dx. Every time you differentiate y, you must write dy dx. Now differentiate sine, I'm getting cos x. Now the next step, remember, is to do what? The next step is to solve for dy dx. So I'm multiplying both sides by y. So my dy dx will be y cos x. Your final step, every time substitute back your y. So if I substitute back my y, I'll have e sin x times cos x. That's my final answer. Remember, from here your y is e sin exponent sin x. Okay, let me take one from the question paper and we work through it. Okay, now we have y. Let's say solve this using your logarithmic differentiation. So we have square root of x squared minus 1 times tan 4x over ln x. So remember, our first step every time, apply your natural log both sides. So I applied, so I didn't change anything, so if I only applied my natural log. So we know that natural log, this is where we started when we were talking about the operations of natural log. We said if I have a log of a product, it's the same as saying it's I give each expression its own log and I make a sum. So this will be this one alone plus this one. Then your ln x, it's dividing, so which means it will be, if it's dividing, it's minus ln of ln x. You see that square root of x minus 1, that tan for x, that ln x. Then now if I'm here, now I can, okay, let me simplify. Remember, the square root means exponent half, so that half will come before your ln. So now I'm left with this, because it's better to deal with everything without exponents. So this one is ln of ln x. Okay, now okay, this is equals to ln y. So now I can differentiate. Ln y is 1 over y times dy dx. If I differentiate ln of, remember I have half here. If I differentiate ln of x squared minus 1, it's 1 over x squared minus 1 is chain rule times the derivative of x squared minus 1, which is 2x. If I differentiate ln of tan 4x, it's 1 over tan 4x times the derivative of tan 4x, which is 4 sec squared 4x. If I differentiate ln, I'll get 1 over ln x times the derivative of that, which is 1 over x. There. Then now the next step is to do what? Is to solve for dy dx. How do we do that? We multiply both sides by y, because we want to get rid of this y here. Then now 2 and 2 will cancel from our first expression. I'll be left with x over x squared minus 1. The second expression, there's nothing I can do. Guys, maybe your sec squared over 4x, maybe your sec squared 4x and tan 4x can be simplified, but don't do it. There's no need. This one will result in 1 over x ln x. So again, don't simplify. There is no need. Just leave everything as it is. Then your last step, remember, substitute y always. So our y was square root of x squared minus 1 tan 4x over ln x multiply by x over x squared minus 1 times plus 4x squared 4x over tan 4x. This is a good thing in N5. We don't simplify anything. We don't simplify anything. So that's why when you do normal differentiation, you just write your answer in one step. Don't simplify. Okay, let's go to the next example. Okay, next question. They say they gave you equation. They say given a particle moves along a line such that the displacement in meters in time seconds is given by. So they gave you a formula for displacement. They said st is equals to t exponent cos t. So they're saying an object moves in a line such that the displacement is this one. Then the question, they say determine the velocity. So they want velocity at t equals to pi over 4 seconds with the aid of logarithmic differentiation. So remember, velocity is always the differentiation of displacement. Then acceleration is the differentiation of velocity from our rate of change then. So which means we have to differentiate as respect to time using logarithmic differentiation. Remember the first step. So there's no need to write st. You can just write s equals to t cos t to make to make it easier to work with. So remember, first step is to apply ln both sides. What happens this side if I apply ln? Your cos will come before your ln, then ln t will be there. So now we can differentiate. If I differentiate s, I have 1 over s ds dt because I'm deriving respect to time. Now if I differentiate, if you check this 2, now this 2 is a product rule. So my product rule, I'm starting with u times the derivative of v plus v times the derivative of u, which is minus sine t. Then the next step is to do what? Is to solve for ds dt. So if I solve for ds dt, I multiply both sides by s. Then here the first one I'll have cos t over t. The second one I'll have minus sine t ln t, or however you write it, but don't forget the minus. Then don't forget your last important step, to always substitute your y. In this case it's s, we didn't have y, so I'll substitute my s, which is t cos t multiplied by cos t over t minus sine t ln t. The question, this is your velocity equation now. The question is, they wanted you to calculate the velocity after time is pi over 4 seconds. So what does it mean? It means where there is t, I'm going to substitute pi over 4. That's what it means. Cos pi over 4 over pi over 4 minus sine pi over 4 ln pi over 4. Remember, to do this, your calculator should be in radians. And like I said, every time make sure your calculator is in radians in N5. You don't deal with degrees anymore. So let me substitute and see. Okay, so I'm getting 0.903. This is meters per second. Don't forget, don't think I was quick to substitute. It's because when I'm recording, I can pause and substitute, then continue. So it's like I didn't take time to do anything. Okay, yeah, so that's what I get. Now, last question. Okay, this one, let's see. So these questions I've been doing is from past exams. So now the one I'm doing now is from 2016 August. And this one is question 2,3 for 4 marks. We're saying solve this with the aid of logarithmic differentiation. You have y, it's 9 minus x cubed exponent ln x. So remember, first step is to apply ln. So if I apply ln, this ln at the top will come here. Then remember I applied ln. Okay, in case you didn't get it, remember the second step from here can be this one. You apply ln both sides so that we clear some confusion. We know this ln will come before here, so that's what happens. Ln x, ln 9 minus x cubed. Then after here, you can see now if I differentiate, I have product rule here. So the first thing I'll have 1 over y dy dx. The second step I'll have product rule. Product rule, it's u times the derivative of this, which will be 9 minus x squared times the derivative of 9 minus x squared, which is minus 3x squared, plus v, which is this, times the derivative of the other one, which is 1 over x. So now if I solve dy dx, I must multiply both sides by y. So inside the bracket, so remember you can start this however you want, but I can see this term here is positive, so I can decide to start with this term. So I'll have ln, but you can write it however you want. I'll have ln of that over x because it's multiplying 1 over x. Then this one, it's negative, so it will be negative 3x squared ln x over 9 minus x cubed. Then don't forget your final answer, always substitute your y. Then I have this. I hope it's clear. This was our final example. So you just check as many examples as you can after seeing the video so that you don't forget. Okay guys, don't forget you can leave a comment or email me any problem you have. Okay, thank you. I'll see you next time when we discuss something else. Goodbye.